Hi, Jeff Mucklin here. I'm with the Nurture Nature Center, and this is Science at Home. So we are talking about volcanoes today. Now, volcanoes are certainly one of the more visually dramatic kinds of natural disasters that we experience here on the Earth. You may have seen video clips or pictures of volcanic eruptions, and they look quite apocalyptic, with fountains of lava bursting from the interior of the Earth. And for some people, those volcanic eruptions have been the end of their lives. One of the most famous examples would be the ancient Roman city of Pompeii, which was buried under a cloud of ash, and its citizens were forever entombed in that material. Now, volcanoes don't occur, evenly with equal likelihood over the entire Earth. There are some places that are far more likely than others to experience volcanic activity. And in this data set, I can show you those areas. Anywhere where you see orange dots, these are places where we see underwater aquatic volcanoes. And anywhere where you see a red dot, those are places where we see volcanic activity on the surface of the Earth. And you'll notice that they are clustered. There are certain places that seem to form these great lines of volcanic activity. And there are other areas where we don't see any volcanic activity for thousands of miles. For example, if we look at the Pacific Ocean, in the middle of the Pacific Ocean, there's really hardly any volcanic activity at all. But all around the Pacific Ocean, for example, here along the coast of South America, along the western coast of the United States, and then going more into Asia, we see this line of volcanic activity, either on the land or in the ocean. We call this the Great Pacific Ring of Fire. Why is this occurring? Well, the reason is because the surface of the Earth is broken up into individual plates that actually move around independent of one another. I'm going to put the plate boundaries on the sphere now. So these are the individual plate boundaries. These individual areas move around independent of one another. And if you recall, the volcanoes appeared along these same white lines. The movements of these plates relative to one another kind of determines how likely we are to see volcanic activity. Sometimes plates move sideways relative to one another, like this. And that kind of motion typically isn't associated with volcanoes. It's more associated actually with earthquakes. But if the plates are moving towards each other in a convergent plate boundary, that can produce volcanoes. And a lot of the volcanoes that we see on the land are in convergent boundary areas. And if the plates are moving away from each other, that's a divergent plate boundary. That is typically what is associated with the volcanoes that we see underwater, these subsurface volcanoes. In either case, a volcano is just an area where the heat from the interior of the Earth is able to reach the surface in some way, typically due to one of these features. One of these plate tectonic features. Although there are exceptions. Hawaii, for example, is very volcanically active, and Hawaii is nowhere near a plate boundary, as you can see right here. If there is a lot of gas dissolved in the rock that is moving through a volcano, in the liquid rock that is moving through a volcano, when it reaches the surface, that pressure can be released very suddenly. We can have a very explosive volcanic eruption. That's particularly dangerous. In other cases, there might not be a lot of gas built up in the volcano, in which case we see a more effusive eruption. We see fountains of lava. Lava is rock that is so hot it is liquefied. There's lots of this material inside of the Earth, but when we are looking at when we're talking about liquid rock inside the Earth, we call it magma. But as soon as it reaches the surface of the Earth, we call it lava. For those volcanic eruptions that occur deep under the ocean, deep beneath the surface of the waves, they don't affect people very much. Here's an example, a video clip of a volcanic eruption that occurred, about half a mile below the surface of the Earth. That's quite deep. Here you can see it. This is some of the first footage ever taken, by the way, of a volcanic eruption that deep. You can see the liquid rock encountering the water right here. Really exciting footage. Here we can see bacterial mats that are surviving off of the chemical brew that comes out of these fissures that are associated with these underwater volcanoes. A good example of a volcanic eruption that occurred on the land and caused significant disruption would be the Icelandic volcano Eyjafjallajökull, don't ask me to pronounce that ever again, which erupted back in 2010. And it produced an ash cloud, which you can see here. And that ash cloud was considered very dangerous for aircraft. And so for several weeks, airplanes were not able to fly over Europe, which has some of the busiest skies in the world. It caused major economic disruption. Another very powerful volcanic eruption occurred earlier this year in January on an island in the South Pacific region, north of New Zealand. This Hanga eruption was one of the most powerful volcanic eruptions that has occurred in our lifetimes. It was really spectacular, very powerful eruption. And it was so powerful that a large amount of material was ejected into the upper atmosphere, into the stratosphere, which is unusual for dust and water vapor to reach the stratosphere. And that should have a climactic effect that will play itself out over the coming years. Not all volcanoes are bad, even when they occur on the land. For example, the Hawaiian Islands, you can see them here, owe their existence to volcanic activity. There is a hot spot in the middle of the Pacific Ocean, and as the Pacific plate moves, that hot spot keeps punching through and creating a series of islands. Now, when we look at the lower 48 United States, you can see that there's plenty of volcanic activity on the west coast of the United States. You might be familiar with some of these volcanoes. One of the most famous of these being Mount St. Helens, which was a very powerful eruption that occurred in some of our lifetimes. There's also a very large volcanic hotspot in Yellowstone. Actually, the entire Yellowstone area is a super volcano, something we'll have to talk about some other time. But if we look at the east coast of the United States, you can see there's no hint of volcanic activity here at all. At least there isn't today. There was volcanic activity on the east coast of the United States in the past. The northeastern United States hasn't been geologically or volcanically active for hundreds of millions of years. So the crust of the earth in this part of the country is pretty cold. But I'm in the one place on the East Coast where there has been some volcanic activity in the last couple tens of millions of years. I'm in Berkeley Springs, West Virginia. There is a area of hot rock deep underground here, but close enough to the surface that groundwater is heated up by that hot rock. And when it comes up to the surface, the water is pretty warm. It's about 74 degrees Fahrenheit. So in our area back home, the ground temperature is around 52 degrees, and so groundwater, water coming out of, say, springs, is going to be around that temperature. In this part of West Virginia, the ground temperature ranges between about that, 52, up to 62 degrees Fahrenheit. So that means this water, which is spring water, should be at the hottest about 62 degrees Fahrenheit. Here in this pool of water, the temperature's more like 74 degrees Fahrenheit. The water is this warm because of geothermal activity, because of extremely hot rock deep underground. So why is there all this heat in the ground in the Virginias? Well, it's because of the volcanic past in this area. Right now, I'm at the top of Mole Hill in West Virginia. It just looks like a tree-covered hill from the distance. But this is actually, what I'm standing on now, is the summit of a extinct volcano. Now, this hasn't been an active volcano for over 47 million years. Well, I hope you've enjoyed learning about volcanoes with me. If you have, here's a fun at-home activity you can do. It's the classic baking soda and vinegar volcano activity. It's very simple. You just build a model of a volcano. I made mine out of clay right here. And then you put baking soda and vinegar into your volcano. You put the baking soda in first, and then you add twice as much vinegar to that mixture. When you mix baking soda and vinegar, you make a chemical reaction that produces lots of carbon dioxide gas. So that baking soda and vinegar volcano was pretty cool, but I'd like to up the ante now. For those of you who know much about chemistry, you might know that the thermite reaction is one of the hottest exothermic chemical reactions that you can produce. When I ignite this powder in here, we're going to make a liquid, rocky, metallic material about as hot as lava. This is the closest I can get to a real miniature volcano with actual lava near the bottom. So that was pretty cool. We just produced the thermite reaction, and down here, this red hot material is essentially lava. I can feel the heat from it, even from a distance. Never do anything like that at home, of course. But that was pretty exciting. I hope you enjoyed that, and I hope you enjoyed learning about volcanoes, and I'll see you next time.